When we put Cilla out there, again, as a result of the pivot, that was actually our marketing strategy. There were a couple of blogs from Netflix. Netflix was one of the heaviest users of Cassandra at the time, in which they were touting that they managed to scale a Cassandra cluster to 1 million reads a second. And then the whole cluster, like the whole group of machines, could do 1 million reads a second. So you had a Cassandra cluster that could read 1 million queries a second. And we actually managed to get one single instance of Cilla doing 1 million reads a second.
I'm so excited that you reached out to me on Twitter. Obviously, this is a new podcast, Backend Banter. We talk about backend stuff and the stuff you're doing on the edge with databases, your experience with Cilla. I just think we have a ton of really cool stuff to talk about.
We'll have time. If not, we'll do another one.
Yeah, exactly. Okay, cool. Let's jump right into it. So maybe if you could just introduce to our audience your background, what you've done with, I'm primarily interested in 3 things: Cilla DB, contributions to the Linux kernel, and what you're doing now with Turso.
That's it. And I'm a guy that I've never been one to job hop too much. I've always been like very passion oriented, very project oriented. So essentially I've done 10 years of Linux kernel, 10 years of Cilla, and now hopefully 10 or even more years of Turso. In the Linux kernel, as I said, like that was around the time I started contributing to Linux, around the time I was living in Brazil. So I was still there. That was in 2000 something. So it wasn't really feasible. Today, of course, it is to open a company, get funded. Of course, you could get funded from local funds, but like you wouldn't get to the world. Today, of course, things are much easier. And open source was my way out into the world. I was also like very interested in open source at the time. And I started contributing to the Linux kernel on my own time. And it was funny because I was always like this, a little bit of a contrarian. Even back then, like in 2000, 1999, everybody was moving to other stuff like a web and mobile. Mobile was not a thing, but becoming. And I was like, I don't care about any of that shit. I just want to I like Linux and I like systems and the kernel sounds interesting. I had a bunch of people telling me, you're never going to find a job with that stuff because it's all, who cares about that? I said, I don't care. I just want to do what I want to do. And then I started contributing to the kernel, got a remote job at Red Hat at the time. And I spent around 10 years doing this. It was mostly virtualization. So I worked a little bit, unfortunately, with the Zen hypervisor. I say unfortunately because I truly don't like it. Although I made many friends in that community, I hope they forgive me, but it's a piece of shit. And then with KVM, when KVM came along, I started contributing to KVM, which I liked a lot. And Red Hat eventually acquired the company behind KVM. I became friends with their founders. And when they founded another company, that was around 2012. I was living in Russia at the time, just because. And then
that's an interesting place to live, just because.
Yeah, maybe a conversation for another day. But I spent around 4 years, 4.5 years in Russia. And then Avi and Dor, that were the people behind KVM, they started a new company. And I decided to join them. I was employee number 3. And that's the company that became Cilla. The company did not start with Cilla. We started with a unikernel. If you're not familiar, it's just a kernel that is designed. So we wrote our own kernel. Linux is too boring by now. Let's just write our own kernel in C++. And the idea of a unikernel is that it runs a single process. So you don't have to do memory management, sharing, anything like that.
It's like a single purpose kernel.
Yeah, single purpose. It's not single purpose because it can run general purpose applications, but it cannot run more than one application at a time. And containers were not a thing back then. So keep in mind. So when you think, oh, this sounds retarded, because containers were not a thing. Right. So, and people were doing virtualization with Linux on top of Linux. We essentially had the Linux hypervisor in KVM with a full-blown Linux kernel on top. It was a very heavy way to do virtualization. So the idea was like, maybe we can, instead of putting Linux as a gas OS, we just put this library OS. And it didn't work. Funny enough, there are many companies trying to do this again today, and it might just work. One of the things that I think that changed the landscape is WebAssembly. Because the trick back then is that like you had to change your programs to make it work. Like it was PostgreSQL compatible, but not really. So you had to, because a fork wouldn't work,
like ruin user space and application code and stuff, right?
Yeah. So WebAssembly might be the thing that makes this work, but at the time it didn't work. And then we eventually pivoted into Cilla. I spent around 10 years doing that as well. And then I had a COVID-driven stint at Datadog for a year and eventually founded now Turso.
Amazing. Okay, cool. I want to recap really quick. So you got into open source. Now, with Linux, I talk to a lot of people that have gotten into open source, but I don't get the chance to talk to a lot of people that have actually been big time contributors to the Linux kernel. And you mentioned that, what was it, 20 years ago? The advice was, why are you working on this open source thing? It's not going to make you money. My guess is that in hindsight, it actually was one of the best things you could do. Is that accurate?
Absolutely. Because again, open source is a thing today. And even especially in infrastructure, like nobody today would use a database that is not open source.
Right.
Like it would not consider. But it wasn't the thing. That wasn't the case back then. So you have to imagine that, again, in 1999, the first time I touched Linux, and like open source was not proven. So the advice that I got from a lot of people in my university, professor and stuff like that, is like people still view too much as if open source, it's free, so that means no money, right? There's no money coming to you, so you should be able to sell your work. And even if I would say, look, there are companies starting to do open source. I mean, Red Hat is trying to do open source now, and etc. Because Red Hat would sell like those CDs that they could get like to install Linux, and they were a company. And I think Red Hat changed the game a lot. And Red Hat was one of the most impressive. I was so blessed to having worked at Red Hat at the time. But it was really this non-proven thing. And on top of that, like on top of like open source, it's like you want to be working in the bleeding edge of technology to make a living, that in a sense. So why would you be working on an operating system? Because this is old news. There's still so many, and there is Windows and etc. and the old Unixes, and IBM has a bunch of operating systems. But I think what those people did not realize, and I'm not saying like those people I didn't have access to anybody who was like business savvy or right, those most like university folks, is that innovation doesn't have to come necessarily just from technology. It can come from different ways of consuming technology. So when things change, and by the way, it's one of the things that is changing a lot with the edge, things change, and then you can go back 20 years and say, let's see, what is it that they were doing 20 years ago that haven't made sense in those 20 years past, but now makes sense again. And this is a great way to do innovation, right? Just looking at the world and saying, did anything change in the world that can allow me to do old things in a different way? And that's also innovation. So the way Linux was innovation in that sense, because it was just a completely different way of doing business, right, than what it was before, allowed for so many other things. And obviously, to the folks in your audience today, they're 20, 25, something like that. For them, open source is second nature. Like I saw the birth of Git, because Git, as you probably know, was created by Linus Torvalds because of a fight we had in the Linux kernel. And the quick story is that the Linux kernel used the proprietary versioning system at the time called Beekeeper. And just none of the open source versioning systems worked for a project like Linux that was so distributed. There were a couple of edge projects here and there that would have this need, and then there was a company serving that called Beekeeper. We could use it for free, but the agreement is that one of the things that was, I wasn't privy to the actual agreement, but you can't reverse engineering this. But dude, Linux is not a company. It's just a bunch of people doing whatever the fuck they want.
It's like a mailing list of people. So
this dude, Linus did not reverse engineer it, but this dude did. And a friend of mine actually, he wasn't my friend back then. We became friends much later. And then the guy from Beekeeper said, we can't use it anymore. And for a couple of weeks, everybody thought, oh, that means Linux, what's going to happen with Linux? Because Linux now doesn't have a versioning system. And then Linux just disappears for 3 weeks. Comes back with Git, right? And then today, like what that allowed is that now this thing about writing distributed software, that's what became GitHub eventually. Well, GitHub would not have been possible without that. And again, it's not a versioning system where you think like, can innovation come from a versioning system? It can, because if you have an open source versioning system, now you can allow a social innovation in the way people write code. So it's innovation is funny, it's tricky. It doesn't have to be like a technology that has never been tried before. So Linux was, for me, was very pivotal in that sense, because it taught me all of that. It gave me the opportunity. Again, Red Hat at the time was hiring a lot from the Linux community. Gave me the opportunity to start in international companies, in companies that were doing things for the whole world instead of the local market, which is what I wanted back then. And from there on, I think everything that I've done so far, in a sense, derives from the fact that I've done Linux when I was 17, even though everybody told me that was a terrible idea.
The way I look at it is, it seems to me that contributing to open source is like a job on your resume that you don't have to apply for. Like in my experience, hiring managers look at significant contributions to open source like they look at a job. Like if you're getting pull requests reviewed, like that's a strong signal to a hiring manager that, sorry, if you're getting pull requests reviewed and merged, that's a strong signal that you're doing good work. Right.
Yeah. Again, pull requests didn't exist back then. It was like emails on a mailing list, as you just said. And but absolutely. And another thing is like open source. It also depends on the project. And that was also, again, I didn't do this on purpose, I swear. I started on Linux. Again, everybody, on the contrary, everybody told me it was a terrible idea. But lots of other open source projects that people follow their passions for, even GIMP, like the image manipulation program and etc. It's cool. And you can use that to showcase your skills. And I did a bunch of contributions. At the time, I was very into open source. I've done a lot of small contributions to other projects. That didn't help me either at all or a lot, because the thing is that Linux became this central thing in the economy, right? So now you're not only contributing to open source, you're contributing to this project that is like it's becoming the backbone of the internet.
Billions of dollars depend on this thing. Yeah.
So my advice for folks in the audience is on that is like, of course, especially for the folks that want to do this as a strategy. So I'm just a lucky guy at the end of the day. But like, not only contribute to open source, but try to find a project that is relevant to the stuff that you're doing. Because the GIMP example that I use, it could very well be relevant if what you want to do has to do some with image processing. Obviously, this is a much smaller market than Linux, right? But you find an open source project that is very relevant to the things that you want to do, and you start contributing to it. And if you become a person with significant contributions, even better, because now you're a part of that economic motor, like that economic engine.
Yeah, no, that makes a ton of sense. I love that advice. Cool. Okay, so after Linux, you went to work for, I can't remember the name of the company, but you said the product was Cilla. What was the name of the...
the company that became Cilla eventually, because you end up renaming it, but it was called Claudio Systems, and we were working with the OSV kernel.
Now, Cilla, the only thing I know about Cilla is that Discord switched to Cilla recently.
Oh, yeah. And it's amazing, because I was working, like when I joined Cilla, when it became Cilla, for the first 2 years, I've just really done engineering, because that's like writing the database. But then later, I liked talking so much, as you probably noticed, that I started working with customers as soon as we started having customers. And when Discord first approached us, I started working with them to just make sure. They had lots of problems back then, and it was years and years. So again, I left Cilla in 2020. The Discord thing probably started happening around 2018, 2019, when they first got in touch. Like, and the blog was now published in 2023. So just so you understand, like how in this world of infrastructure, those cycles are very long. They were using it back then, but they were using like already, hey, this thing, that thing, and then it starts growing and growing. But the idea of Cilla is the following. Cilla is an eventual consistent database that is API compatible with Apache Cassandra. So Apache Cassandra was I'm going to guess that some folks in your audience know, but the ones who don't know, it's a NoSQL database, so it doesn't have the same guarantees that a SQL database would give you. It is designed to ingest lots of data, so it was always like heavy writes, workloads that have heavy writes, and it's designed to scale horizontally. By doing this, it's really hard to guarantee SQL levels of consistency, so you become an eventual consistent database. You can write your data there. When you read, you don't really may read the stuff that you wrote, right? I mean, you don't read garbage, but you read data that is stale. And especially because you don't have, back then you had none, today you had some. Transactional guarantees, if you're writing, for example, to 2 keys, you may see an update to 1 key, but not to the other. So your application, it sounds like it sucks, but the thing is, this thing is so fast and can scale so well that for some workloads, for which, for example, the stuff that Discord has, you're willing to make the trade. And I said, I'm going to complicate my application because I'm willing to, and I want to deal with I'm okay with dealing with eventual consistency. And because I need this level of scalability and speed that this thing is giving me. Cassandra was good from a distributed system point of view, but we found out, like with our experience coming from the Linux kernel, the founders were always also people from the kernel. Like, we understand systems programming much better than those folks do. If we just copy the distributed model, but re-implement the node architecture from the ground up, take into account asynchronous I/O, doing kernel bypass whenever necessary, and like doing direct IO, asynchronous IO, and a bunch of stuff that nobody else was doing. How much faster can we become? And Cilla was around 10 times faster than Cassandra in a variety of workloads. So that's my background, performance nerd sniping.
Yeah. I love it. Yeah. Okay, cool. I want to break some of that down because I think to some of our listeners, they'll have grokked a good portion of that. To others, it'll be like, you lost me in the second sentence. Yeah. Okay, let's like break down a comparison between, say, Cilla and Postgres. So for the edification of our listeners, BootDev at the moment runs on a monolithic Postgres database, right?
Good job.
We have pretty solid, we have like pretty small scale. We don't have crazy requirements, and we use like very basic CRUD application for the most part, right? Yeah. You do an exercise, we log a row in our database to say you completed an exercise, etc. Why would someone use something like Cilla over Postgres? Like what does the application need to require in order to make that kind of a shift?
Yeah, first, don't do it, you specifically, because you don't need it. Exactly. And when interest rates were zero, everybody always went for the crazy architecture first. It was always like that, all the crazy. You have something like that, let's do a microservice architecture oriented with a bunch of message passing. Do a monolith. It works for almost everybody. But then when you start seeing the requirements change, that's this, how much data do you have? I'm going to guess here, I'm going to go on a limb, 10, 20, 30 gigabytes of data total about the stuff that your students do. Did I get that right? Just more or less ballpark.
Within an order of magnitude. Yeah,
that's right. Lots of our customers at Cilla had a petabyte of data. And that's the first difference, because a petabyte, 30 gigabytes of data fits in a box. Today, back then, that was about it. That was about what you could fit in a box. Today, you can buy hardware from AWS, like out of the commodity stuff, that can have 15, 20. When I stopped keeping track, the largest box on AWS in terms of storage had something like 30 terabytes. Once you go past that point, it doesn't fit in a box anymore. So you already need the complication of a distributed database. If I'm storing, so think about what kind of things would lead you to need
and when we say distributed,
a petabyte of data.
Yeah. And when we say distributed, we're talking about, okay, I've got one physical machine with 15 terabytes, but now I have 20 terabytes of data. So I need like a second physical machine, and we're going to keep them in sync somehow.
That's about it, right? And also you need to, if you do that, you can shard your data statically and figure out two Postgres, and some students go to one, some students go to other. But companies that have a petabyte of data, it tends to be because their data keeps growing. You need the distributed database will just do all of this for you. It will just figure out like which data goes in which node. And when you need to query, it will figure out, okay, so where is that data? And then there's the variety of algorithms to do that. So there's the first category. The second category is something like how many requests a second do you get to your database of yours in your project? And again, I'm going to guess again that it's going to be 1,000 requests a second at most when a lot of people are submitting your stuff.
Way less, but yes. Way less? Yeah. We're not concerned about it at this point.
Absolutely. And when we put Cilla out there, again, as a result of the pivot, that was actually our marketing strategy. There were a couple of blogs from Netflix. Netflix was one of the heaviest users of Cassandra at the time, in which they were touting that they managed to scale a Cassandra cluster to 1 million reads a second. And then the whole cluster, like the whole group of machines, could do 1 million reads a second. So you had a Cassandra cluster that could read 1 million queries a second. And we actually managed to get one single instance of Cilla doing 1 million reads a second. So that was our marketing material, right? Which backfired, which backfired a little bit because we presented that, and everybody thought, oh, but the good thing is that Cassandra is a distributed system, and yours is not. You do 1 million requests a second.
You only do it on one node? Oh, no.
But what if I need more? And then I said, dude. But then, of course, that was the first thing. And obviously later it became clear that, okay, if we can do 1 million requests a second in a node, then I can do 10 million and a billion and whatever by having more nodes. So like there were those giant Cassandra clusters with 1,000 nodes, right? And we could cut it down to a much lower number of nodes. So those are the things that will make you look into a database like that. Then you think about Discord, for example. Discord uses, as per their blog, for their messaging cluster. So just imagine how many messages are being written and read on Discord all the time by all the people. And then that is a lot of messages and growing because you keep
adding more users.
Adding more users and more messages and a really big amount of traffic coming to this database.
Yeah. Okay. Cool. So you've got this crazy distributed database. You can add N number of nodes, right? You can have tons of nodes in this distributed database. And you mentioned that, so for example, Discord was using Apache Cassandra, which is a very similar type
Yeah.
of NoSQL database. In fact, my understanding is that you use the
API
databases
compatible,
the same
yeah.
way, right?
You use the same drivers, yeah, exactly, yeah.
Yeah, you write the same application code
Yeah.
basically to interact with these databases. The first thing that stuck out to me when I was doing some research on this was that Apache Cassandra is written in Java, and I have a lot of experience with Elasticsearch, so I'm very familiar with this idea of stop the world garbage collection.
Yeah.
Is that one of the key optimizations of Scilla? Is it not using a garbage collected language?
We always said it was. The choice of language was key. But the fact that the garbage collection stuff was not the most important thing. Using a language like C++ at the time allowed us to do a lot of optimizations by being closer to the matter. A lot of that, frankly, was just the fact that we knew how to do that kind of stuff, right? But it was a lot of stuff. The other thing was like the asynchronous I/O, because Cassandra was a database at the time that was based on memory mapping files, and everybody actually thought it was a great idea. All of those, MongoDB was the same thing, and Cassandra was the same thing. They just had this amazing idea. Let's keep it simple. Memory map a file, and then the kernel takes care of that, and etc. And we in the kernel were seeing that stuff like, what the fuck are you doing? Right? This makes this makes no sense, like for a database, right?
Yeah.
And then actually one of my most read articles that I had, I'll send you the link later, you can publish to your audience, is exactly about this. Like I said, just don't do it. If you're writing a database, don't do it. Like, it's stupid. Don't do it. Made some sense, I guess, for those. But the thing is that the hardware was changing so much that with NVMEs, it really didn't make sense to do it. And Cilla was coming up around the same time as NVMEs were becoming dominant. So it was a lot of things. It was the fact that so we could utilize CPU a lot better. You would have a Cassandra node using 20% CPU, and it wouldn't do more than that because it's just like you had a bunch of locks and a bunch of waiting. So if you would look at a Cilla box, it was always like under load at 100% CPUs cranking traffic, etc. So we knew how to utilize the hardware.
That's how you know it's a good program. Like you've maxed out your CPU and your RAM and everything's just cranking.
Exactly. And then the other thing that it's funny is that when people start saying, oh, but you're cheating because of this and that, they say, but no, I'm not cheating. You just don't know what you're talking about. Because when it takes education to the point like you live with those technologies and with those concepts for 10 years. And in that case, it's like the patterns of utilization with spinning disks and NVMe were so different that you had to throw your intuition into the trash when you're looking into an NVMe versus it was not. An NVMe is not just a faster spinning disk; it's a different piece of hardware.
So we're talking about. Can you explain what an NVMe is versus a magnetic spinning disk?
Yeah, so a magnetic spinning disk is something that hopefully you would only find these days in a museum, and it's something that but lots of people still have this intuition today. I know, but you may think, for example, that reading sequential data is faster. So this is one of the things that our industry keeps repeating. So let's lay out.
Just 3 years ago, I had a manager tell me, "Oh, we need to optimize this for sequential reads," and I was like, "I don't think that's a thing anymore."
That's not a thing anymore. Exactly. Yeah. You can optimize for reading larger buffers. That's a thing, but it also maxes out in a couple of megabytes. It makes sense to put some data together on the megabyte boundary, so you can have larger buffers because you're doing less work per buffer. But it doesn't make sense to put a terabyte file sequentially anymore because you don't need to do a sequential scan. That's bullshit. People keep repeating and I don't blame them because we're like for 30 years in this case, because spinning disks, when you read from a spinning disk, you have the seek time. You have to first find the position, and that's very expensive. That's 300 milliseconds. It was at some point, right? And then after that, after your spindle is in the right place, it's faster to scan. NVMEs are not like that at all. You can read from anywhere. You don't have initiation time. You don't have seek time. You don't have anything like that. And again, a spinning disk, because of the spindle, you can do one request a second. And then if you have a RAID array, you can do 3, 4, 5, however many requests per second, not per second, sorry, at the same time. So concurrent requests. On an NVMe, you can do 1,000 concurrent requests, right? So that program of yours that had a semaphore to make sure that not a lot of people are going to the media at the same time, that semaphore that protected you from overload, now it's preventing you from using your CPU because your CPU is generating data, and your disk could take it. But obviously, this is a stupid example because it just makes the semaphore bigger. But when you go look at the architecture you have stuff like that all over the place, right?
Yeah. Okay, cool. And just to be absolutely clear, when we say NVMe, same thing as SSD? Interchangeable
Uh,
words?
in They're not interchangeable words, but from that point of view, pretty much. It's just the transport technology is different, but they both have this from the point of view of parallelism and concurrency, and that it's the same concept applies.
If I squint, it's like the same.
Yeah, yeah. Yeah.
Cool. Okay, awesome. Okay, so you worked at Cilla 10 years. Because this is kind of nice because you kind of broke back
Around
your
8 years.
past
Yeah. Yeah.
yeah, a decade-ish chunks of time. After Cilla, you're now the CEO and founder, co-founder? Is it?
Unfortunately, co-founder, because I have a co-founder with whom I have a relationship of love and hate, which is 95% hate and 5% love. But
Ooh,
the
I
love
hate
is
to
so
hear it.
strong. The love is so
Oh,
strong that I'm always joking about him, and I love that guy to my heart. And like I met Pekka. Pekka was the maintainer of the memory management parts of the the memory management subsystem for Linux was so big. There were many maintainers for subparts. In particular, he was maintaining one of the object allocators. An object allocator is essentially a memory allocator that has like allocates objects for you, not arbitrary memory sizes. And I met him 2009 or 10, something like that, in a conference that we've been together. We became instant friends. He joined Cilla after me, again, to work on this kernel that we were doing. And then we've been to the people. We've been working together since then. So it's been 12 years of Pekka, my co-founder. So we're co-founders together.
awesome. Okay, so with Cilla, my listeners really only need to know about Cilla and how it works if they go to work at a very large company like Discord, or if they work at a very successful startup and start having crazy scaling problems.
Yeah.
With Turso,
Oh,
my
not
understanding.
necessarily. Just to correct that, not necessarily, because if you're doing something like machine learning, then you may have those problems from day one, because
Oh
it
yeah,
really depends. Because it depends on the problem. If you're doing like user tracking and stuff like that, you may not reach a petabyte of data, but you may need an architecture because it's more of a characteristic of your problem than of your scale. The scale obviously matters to some extent, because at very large scale, very small scales, you can do anything anywhere, but the problem needs to be taken into account as well.
yeah, that makes sense. So depending on your domain, but at the end of the day,
Yeah.
it's basically scale of data that we're concerned with. Okay, so Scylla is like at one end of that spectrum. Turso, my understanding, is like at a different end, right?
The absolute other
The absolute
end of the
opposite.
Yeah.
So again, like we
Yeah.
can relate the problem that Turso is solving, again, to what I'm doing on BootDev with Postgres. So like I have this monolithic Postgres database, and it sits in some cloud center in Salt Lake City at the moment. And anyone who accesses like the BootDev application, their computer connects to my server, which is also in Salt Lake, and that server connects to the database, which is right next door to it. Right, it has a really fast latency time, and my server communicates very quickly with my database. But my users can be quite far away from my server. Right, someone browsing BootDev in India is going to have to make requests all the way across the world in order to interact with my website. So tell me how Turso deals with this issue.
Yeah. So first of all, Turso only makes sense in a world in which people are already, which they are, already looking at the problem of, okay, but now for those users in India, how can I serve them better? And in all fairness, people have been looking at this problem for a long time. And the usual solution for this problem is like the static parts of your application go to a CDN, right? The user in your example in India, let's go further, man, like in Australia or Japan, right? So just really the other side of the world. So you have this user in Japan, and the user will go to your website, and hopefully your static assets will come.
Yeah, our front end is
CDN.
on a CDN,
Yeah,
exactly,
right? So this is already the way the world works for a while.
HTML, CSS, JavaScript,
Yeah,
they're getting
exactly.
into your browser real quick.
Yeah, everything that doesn't change is there. So what we've been seeing, though, in the past couple of years is that this is starting to feel, because technology is always like that, right? Technology doesn't exist in a vacuum. You solve one problem, and then this one problem leads to the next problem, and so on and so forth. So I mean, Turso wouldn't make sense 5 years ago, because the use cases were not calling for this. But what started to happen is that now you want to add some personalization to those static assets that you just served. You wanted to display something, you want to do some transformation, and there's something that you might want to do to serve those users in Japan a little bit better.
I want your user profile to show up a little quicker.
Yeah.
Right?
Let's not even go into the user profile. Really, just things that you can do with code and no data, right? Just that you want to do some rendering, like some specific render. Like
I want to show the dollar value in like your local currency.
Exactly, something like that. You can go with a static table and etc. But you want to do some transformation, some personalization based on that. So now it will be fantastic. Anything that's server side, think about something that is server side on your application but doesn't touch the database. You want to do that for that user before you load that page. So you would love to execute that code as close as possible to that user in Japan. Now, it doesn't make sense for you to have a bunch of AWS servers and a bunch of AWS regions all over the world. Again, which is why, again, the problem was already there, but it's why this wouldn't have happened 5 years ago, because that just doesn't make sense. What changed the game a little bit is that the CDNs themselves became programmable, like something like Cloudflare workers. Now you don't have to worry about the server stuff. You don't have to worry about having a complex, crazy architecture that doesn't make sense for your startup. That just to deploy those servers, give me a function and I will execute that function as close as possible to my user, right? And a lot of the WebAssembly platforms are starting to look into this direction again for things like Python and Go and etc. So let me execute a serverless function close to your user. And it's super simple because, again, I know where your user is coming from because I have the CDN or the edge network, as you may want to call. Now added code capabilities to my edge network. I can execute that code. I can do some personalization and whatever. There you go. Your Japanese user is super happy.
Right.
But when you want to serve the user profile that touch the database, you're still coming to Salt Lake City. So that's the thing. And that's what we're trying to solve with Turso. So with Turso, we want to make sure that your data is also everywhere so that now you can really have your user profile, your personalization code, the result of your A/B testing, your LLM models, your embeddings, and all the stuff like that. We're not going to be the database that cranks the training model, but we can be the database where you store the embeddings in Japan and in Salt Lake City and in India and in Paris and in Brazil and in Argentina, all over. So again, not very good for writes because to distribute those writes all across the planet, that is expensive. Unlike Cilla, for example, Cilla was all about like millions of writes a second. This, you can do maybe 10,000 writes a second, right? Just
your writes blow up, right? You go from one write to 100 or something.
Pretty much. But still like 1,000, 10,000 reads a second covers a lot of applications. But now you can read from all of those locations. And hopefully you can scale those locations independently. So you can serve more reads from, if you're having more traffic from here and then you're having more traffic from there, you can essentially make sure that those things happen independently. So that's the story of Turso. That's the value that we provide. You're absolutely right it's a completely different problem than the problem that we had at Cilla, which calls, of course, for a completely different solution. But we just saw the edge becoming more and more important and functions and geographical distribution. And we figured that we could bring a solution to that.
Which I think this is one of the things that best differentiates a good engineer, or especially a good backend engineer, from a bad one or an inexperienced one. Mm-hmm. And it's like not thinking that a piece of technology is just the best because it's new and it's hyped up. Like we need Cilla for this. Yeah, go ahead.
I on Twitter the other day, somebody was, because our database is based on SQLite, right? And I can talk more about why that's the case. Somebody said, "Oh, are you trying to tell me SQLite is better than MySQL?" And I said exactly this. I said, we have one piece of technology in our industry that is objectively better than anything else, which is Vim.
Objectively better than NeoVim?
Oh yeah, for me, like I started using. You have to understand that when I started using Vim. Vim did not exist. It was just VI, right? Over SSH. So for me, they're all a family, right? They're all a family of,
and that family is better than Emacs.
That family is better than anything else, like VS Code or VS Code is essentially you versus code. It's in the name, right? Versus code.
You versus your code. You have to fight your application.
Yeah, that's right. All the rest, right? There's no such thing as better. You can't. There is better, but before you talk about better, you have to select which metric matters the most.
Right.
For you. Once we're talking about the same thing, then I can talk about better or worse. because people keep saying, oh, but this database is faster than that database. But no database is faster than any other database. They're faster at different things usually. And then they cost different amounts, and they cost different amounts in different workloads. So you can't really talk about better before you define a axis and say, okay, now let's compare that, right?
And they have different costs in different metrics as well. You could have a complexity cost versus a licensing cost.
Absolutely.
Like, it's an explosion of complexity,
yeah.
which I love. That's why we're all paid to do what we do.
I'm not paid to do what I do. I pay other people to do what they do. Like, I'm a founder now, so like a life of a founder, man. Life of a founder is hard.
Yeah, we don't make money as fast.
We don't make money. We're hoping to make money all at once in 10 years. Just
someday.
But someday. Yeah.
I'm right there with you. Yeah. Okay. So I explored the world of serverless, I think, too early. And now I need to go like re-explore it. This is back in 2017, 2018. I was playing around with like Lambdas. They were fairly new on AWS, and they were exactly what you described. Basically, I can give AWS some function and they'll execute it, and it scales infinitely and all these really nice things. But immediately, of course, the problem that I ran into was like, this is silly for a couple of reasons. First of all, cold starts. What's the point of scaling to 0 if once I scale to 0, like my application sucks? It takes 5 seconds to start up. All of a sudden, my web application feels awful when I'm like demoing it to my one customer. And then the other problem, of course, is the one that Turso is working on, which is that like my database is monolithic anyways. Like I'm putting all these Lambda functions in front of a Postgres database that's sitting in Salt Lake City. So there's really no point. Okay, so what has shifted? You mentioned there's been this technological shift. What has made this like a better idea now than it was, say, 5 or 10 years ago?
So people still complain a lot about the cold start problems, but I do think it's a lot better now than it was before. By the way, we have a bunch of ideas that we haven't implemented yet, just out of time, on how to, and we mostly keep it as isolated from users, right? But on even at the database level, be able to scale to 0 with unnoticeable cold starts. So there are more technologies to handle this kind of things today. And again, I don't want to minimize the problem of cold starts. I do think there's still one of the biggest problems with serverless. But keep in mind that they're also a very similar problem than people complain with just-in-time compilation, right? So lots of Java applications, they had just-in-time compilation, and then you benchmark and say, for 5 minutes, those applications suck. But after that, they don't, so that's fine. And it sucks if you're really showing demos that don't last 5 minutes, but when you have a long-running thing, that will really not. So the main advantage of the serverless in that case is not that it can scale to 0, is that it can scale from 1 to 2 to 3 to 4 independent, which is why I think that it will take still a little while before you actually completely solve the scale to 0, because the biggest value is still in what comes after that. And a couple of things that shifted is that I just think that the technology got more mature. It got more available. It got deployed in more places, and a little bit of market education as well. Lambda is not the only game in town. You have things like Cloudflare Workers, and Netlify for the TypeScript folks also has edge functions. And also, I think the geographical thing is also a factor, because again, you were using Lambda. Lambda is not that transparent as far as I understand. I may be wrong on that. Just a disclaimer: I'm not a heavy user of Lambda. I know of Lambda from reading and etc. And also those things obviously change very fast. But my understanding of Lambda is that Lambda focuses a lot more on the function execution side of things, and a lot of those edge platforms today focus on the fact that your application will run across the planet transparently. So there is it's essentially, again, it might look like a minor difference, especially from a technology point of view, but it can be a big difference from the business point of view, because now you can use that infrastructure to serve your users wherever they are.
You're saying it's less about the scaling and more about the geographic distribution?
Yes. And again, one of the things that I love about the edge, and once more, you could have done this with AWS 10 years ago by having machines in all of those regions. And it's also one of the things I love with Turso. You can spin read replicas. We keep hearing this, which is, again, for me, reminiscent of Cilla. Because when we started publishing the first benchmarks with Cilla, everybody's, oh, you don't understand the problem. I said, come on, of course I do. You're cheating because you're not showing this and that. And one of the things, for example, Cilla scale on the hardware side very well. So people were running Cassandra on those small 4 CPU machines. And then, but because Cassandra wouldn't scale vertically past that, you would run it on an 8-core machine and you would get 20% improvement. So why would you do it, right? But Cilla scale linearly on the size of the machine. So we were running those like 40 core machines, And what we heard the most is it's not fair because, of course, you can cut the number of machines because we increase the size of machines. It's not fair. People think that fairness in a benchmark is all about everything has to be the exact same. And it's not like that. Because look, I would rather manage a fleet of 3 machines than a fleet of 1,000. So if I can increase it both vertically and horizontally, amazing. So at the end of the day, what matters is the business problem, what you want to do, and then you just do it. And we're hearing a lot of similar things with Turso, which is great. For me, it's a sign that we're on the right track, which is like, of course your latency numbers are great because you have replicas everywhere. Yeah, because we can. Hello.
Replicas everywhere is not an easy problem
exactly,
necessarily.
Right.
Yeah,
exactly. So first off, if you've got a database like Postgres and you want to put replicas everywhere, it's costly. Number one, you're going to be paying a lot. And again, our scalar plan that's coming up, our free tier with Turso allows you to have 3 locations. So for free, you go sign up for Turso. For free, you can put your database in 3 places. For $29 a month, which is coming in a month or 2, you can put your database in 6 locations, right? So the first thing is the cost of that. And the second thing is that if you have those machines that are distributed, if you happen to be willing to pay the cost of putting those machines everywhere, now your application logic needs to figure out which database to hit. And with Turso, like you just hit our single endpoint and we find the right replica for you. So
how does that work? If let's actually just use a super concrete example because this is really interesting to me. So BootDev as a platform, as we mentioned, is like this monolithic application and it's a B2C product. So I have consumers all over the world learning backend development on BootDev. So I actually would love to, over the next N months or years, be looking into how I can use Edge to optimize like speed times basically for my students. What needs to change in my application code? What re-architecting needs to happen to make BootDev, which you can again think of as like this pretty simple transactional model? You log into the site, you've got your user profile. When you complete exercises, we're marking rows in a database. What changes so that I could take advantage of Turso?
Yeah. So I don't know where you're deploying your application today, but the first change that needs to happen is that you need to move your code. Forget the data. You need to move your code to a platform that does this geographical distribution for you. Because I started talking about Turso as an example, but the question that you're asking was specifically about serverless and stuff. And the thing again, if you need to execute a function, but you still need to worry about where the function is executing, that's still not that convenient. And what things like Cloudflare Workers will do for you is that you don't have to worry about that. You push the function and the platform cares about which is the thing that we're doing with Turso at the database level. And now you have this perfect match in which your code, the platform that runs your code automatically figure out where I'm going to run this function. And then the database figure, okay, where am I going to go to fetch the data from? So now I put the data. Turso is a single logical database. That's the thing. It's not a database with a bunch of replicas. It's a single logical database that finds the best location for you at any given time. So the first architecture is that you need to move your code to some serverless platform. Let's say
doesn't that need to happen at the same time? Because like I imagine if I took my existing code, broke it up into like serverless functions, or maybe if I can even run the whole app serverless, that say I have an endpoint currently that has 3 or 4 round trips to the database. If I move it to the edge, but now the edge is far from Salt Lake.
No, that doesn't have to happen at the same time, because now the edge is far from Salt Lake, but it's closer to your user. So at the end of the day, so now the user before would take 200 milliseconds to get to your server, and the server will get you the database very fast. Now, if you move to a code edge architecture, the user can get to your server in 50 milliseconds.
But in my experience,
but it's still about the same. Am I making sense? Because the real trip is not from the server to your database. It's the total. The real time is the total time between user and the user getting what they need. And there might, look, when you're migrating something, shit breaks. That's the rule of life. So there might be a use case that becomes pathological. Sure. But I don't think you necessarily have to do those things at the same time. You can do them in increments. Look, first you move your code. Again, if 100% of your code is always talking to the database, sure, move both, might as well. But if you have, for example, some code that doesn't touch database a lot and some code that does, you can benefit from moving the code first. and then moving the data later. That's not me saying that you you can't do both at the same time. But we're engineers, man. We know that shit breaks and etc. So you want to move one thing first sometimes. You can do that. So it's perfectly possible. Turso is SQL based. Go ahead.
I was just going to say, this is why Turso is so interesting to me, because in my experience, again, it's a backend doing a lot of like CRUD application type stuff, right? REST APIs. If it were the case that user talks to server, say it takes 1 second, and then server talks to database and takes 50 milliseconds, and then it goes back, you've got like a total round trip of 1 second, 50 milliseconds. Then that's easy. We just take the function and we move it closer to the user first. The problem that I see is that like with 90% of apps I've used or that I've written and worked on, the server talks to the database like
a lot of times,
2, 3, 4 times synchronously, right? First, it does like an authorization check and authentication, and it does a couple business logic round trips. So moving the server close, like that would be the logical step. But I know that at least with BootDev, for example, I'm like checking if you got achievements and all this stuff. I did it with especially 5x.
Especially if those requests depend on each other, because if those requests are independent, you can fire them in parallel. But if those requests depend on each other, now you can't. So again, you're right. And it's interesting because the Vercel, one of those companies in the TypeScript, JavaScript world, they recently published a benchmark with comparing edge databases. And there are some things in that benchmark that I did not like. There are some things that I did. And one of the things that I did was the fact that you could simulate the benchmark with a single request or with 5 requests. Because again, that is a lot more realistic, right? So again, it's closing. And some people say, again, it's unfair because it's replicated and in this case is better for you. I said, no, it's not unfair because this is how people use databases, right? So in a benchmark, you always want to get closer to real life. And another thing that you can do with Turso is that those replicas are quite ephemeral in a sense. So you can, ephemeral in the sense that they're long-lived, of course, but it doesn't take an hour to replicate. And also, we're not dealing with the level petabyte kind of scale that we've dealt with Cilla. For a scale like yours, it would maybe take 30 seconds to a minute to replicate. So you can run a replica in Japan for a day because you expect that in that day you're going to have some event in Japan or something like that. And then I said, now you don't need that anymore. I say, okay, shut it down. And now you're not paying for that anymore. Right? So just agree with you, as I said. So if you have a workload like this, you can move your serverless functions to global, and then you move to Turso. To do that, now you're covered because whenever the user hits the server, will hit the database 4 or 5 times, but your database is now made close. And to fully answer your question, what do you need to change is the first is the code architecture that you just decided to move it at the same time. So let's help you with that. The second thing is just the database accesses. And Turso is not Postgres. It's not based on Postgres, but it's based on another database that is SQL based. So there are some differences, but SQL is by and large the same. Right? If you're moving from one SQL database to the other, there are some differences and you need to get used to some of the stuff. It's a lot simpler of SQLite, which is our underlying technology.
We teach SQL and SQLite on BootDev. Yeah,
exactly. So your users, for example, and also Turso also runs locally. The Turso drivers also run locally. So another thing that I love is that now you can use those local files to run your CI, to run your test. Imagine like testing databases before Turso. Like you spin up a container and you do this, or you create an account, a free account in your serverless Postgres provider. Like with Turso, you can run all of your tests locally. You can do all of the development locally because the SQLite experience keeps working. One of the things that we have on the website, the SQLite developer experience now on the edge, because when you point your driver to a file, you talk to a file. You replace that URL with, instead of SQLite blah, 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 to HTTPS something, now you're talking to Turso over the network. And it's the same code, it's the same driver, it's the same everything. So you get you port your application from Postgres to SQLite, make sure it works locally so you don't pay any server bills in the meantime. And then you deploy to Turso, and there you go.
That's awesome. Okay, so I want to just really quickly talk through just from a high level, what the application code looks like. So let's assume that BootDev is all distributed on serverless cloud functions, right? Edge distributed. Each one has a connection string. And this was like really interesting to me. The connection string to the database in every geographic region you mentioned will be the same.
The same, yes.
How does that, like from a high level, how does that networking work so that like latency is avoided? I'm not like going to one central location and they're getting redirected.
Yeah. So again, we essentially have a router. So when you're contacting, when it's the same technique that would happen between the client and the edge provider, right? So when you're hitting the edge provider, you're hitting a unicast address that can then pick the address that's closer to you and route you directly to there, right? So you have your CDN. So we have parts of Turso in the CDN. That, long story short, without going in lots of architectural details, that's how it is. Parts of Turso, like the entry points of Turso, are also at the edge level.
And so your logic that runs on a CDN is now connecting to a database CDN.
That's right. Yeah. So the database is still distributed, but I will figure that out for you. You don't have to figure that out. And you contact me. By the way, some people still do this, some people don't, but there are people doing client-side database access. That can happen sometimes. Why not? Especially because we have read-only JWTs. All the access to Turso is done with JWTs, right? So you can have read-only JWTs, and you can have a table. Essentially, they can just say of this or database.
Database style, right?
Yeah, yeah. So it's not impossible to do. I'm not advocating for that, because every time they say, "Oh, SQL injection," blah blah. So I'm not advocating that you allow this on the client side, but you can do this on the client side, and it's the same thing. So your client will now connect to, instead of going to the server and then to Turso, you connect to Turso directly, and it's as if you were you get to that single address. Your client gets to that address. The CDN already picked the address that's the closest to you. And now I will see, of all of the locations where you have data, what is the location that I want to route you that is closest to you.
Oh, fantastic. And for everyone listening and not watching, right after Glauber said he didn't advocate for it, he winked like big. So.
No, I don't care, man. It's just yeah.
Oh, fantastic. Okay.
I don't want to pick that fight. I can pick other fights if you want, but that fight is like it's server side, client side. People have different opinions on that. Just, I don't know. I'm a database vendor now, so you can access from, it's your problem and it's not mine.
Yeah, that's a good point. Throw it over the wall.
We want to support as many use cases as possible.
So one more question that I have about Turso in regards to, I guess, like what my experience as an application developer would be, or how it would change. I'm currently using Postgres, and I'm actually a big advocate of, when you're designing web apps, to not use like crazy database specific features unless you like really need them, for exactly the reason we described earlier. If you use kind of very simple SQL in your application, assuming you can get away with it and assuming it doesn't affect performance, then like you're portable at that point, right? Absolutely. Very easy to switch vendors, very easy to switch technologies. But I've done a lot of SQLite. Like I said, the SQL course on BootDev is done in SQLite. And really the only complaint I have about SQLite is this loose typing situation.
Yeah.
Has that been a problem with your clients? Is there any concerns there? Because obviously, like, while I don't love TypeScript, I do love static types.
So first of all, I came from C, C++, later Rust, and etc. I'm going to offend some people now. I'm feeling that. But
sure.
I never understood this discussion that some people have, especially in the Python and in JavaScript community, whether or not types are great. What are you even talking about? It's obviously like, why would you not type things? For me, this is so obvious, right? That the whole discussion doesn't even make sense to me. And this discussion happens a lot in the JavaScript community because they have JavaScript and TypeScript, which are the same, but with types. And should I use types? And the discussion looks crazy to me, because for me, it's like, I would have to move languages to use.
Do you want to know what your data is?
Yeah. And for them, and for them, is like, I can keep the same language, but I have the option of using types or not. So this sounds crazy, and why would you not do it, right? But so that I fully support typing. But the thing about it is that at the database level, I wish, and maybe this is something that we can do. For example, Turso doesn't run on pure SQLite. We have a fork of SQLite called libsql that is open contribution, by the way. So SQLite, as you might know, is not open contribution. They don't take contributions. They are open. They're not open source, technically speaking. They're public domain, which is like even more lax than open source. But it's very rare that they can take. They don't have a community of contributors, like even if they take individual contributions. So we fork SQLite and we have libsql on top of that. So we could extend that at some point. But this is not a complaint that we heard yet in a massive way. And I think the reasons are twofold. The first reason is that, again, people who are reading our message and see Turso, they read the developer experience of SQLite on the edge, they already know what to expect, right? So if they decided to use Turso in the first place, it's like coming to JavaScript 10 years ago and complaining you don't have types. Okay, fine, but if you cross the chasm, it's because you want to use this for other reasons. And
right.
And I think the other more important reason is that most of the time people are accessing databases through your programming language, right? And your programming language hopefully has types, and then you have schemas, and then you have ORMs, and you have stuff like that. So your experience as a programmer is to deal with types. The fact that the database decided to store a date as text is not necessarily visible to you if you're going through an ORM, which lots of people are, because your code will show you as a date type. It's just
right. Awesome. That's fantastic. That's all I wanted to hear. Now I need to go spend some time checking it out. Where can people find more information about serverless edge databases, and then B, where can they find Turso and whatever you're working on?
Yeah, so Turso, we are at Turso. That's for those, so again, not necessarily seeing that, but the turso.tech. So that's our website. You can find us there. And I don't know, I think information about serverless, that's pretty broad. Like it's like people asking me, sometimes people ask me, do you have any books that you recommend? Because I'm learning A, B, and C. And I'm not a book reader. Tech, when it comes to tech, right? Because
they just need to go find all your podcast appearances.
Yeah, it's just because I think the internet kind of replaced that for me in a sense. I think the last book that I read on tech was in 2006. Packer's not like that. Like, by the way, my co-founder, he reads a ton of books, but I don't. So I don't know of any one place, right, in any format that you can go to read about serverless. Just that there's a ton. What that means is that there's a ton of resources out there. We talk a lot about that stuff in our community as well. So we have our Discord community. Everybody's welcome to join. It's a merry band of people just excited about Edge and serverless and databases in general.
Fantastic. Go check out turso.tech. You guys have a blog too, right? Then go read about Turso.
We do.
Stuff.
So from the website, you can reach the blog. And our website is really the central place for a lot of that stuff. So we have a blog and we have our documentation as well. So our documentation hopefully will also teach you a bunch of core concepts about serverless as well.
Amazing. Thank you so much for coming on the show. It really was amazing talking to you. I had such a good time. And
likewise, man. Likewise.
We'll need to do this again sometime.
We will. Absolutely.